Hello everyone. Today we'll study section 3.7, Antiderivative. Before I introduce what it is, let's do some review for derivative first. Derivative of a constant is always zero. Let's call it a constant rule. Derivative of x raised to the power of n is always n times x to the power of n minus 1, which means I bring exponent to the front and reduce the power by 1. Let's call it a power rule. Next, for derivative of a constant times a function, its derivative is the constant times the derivative of the function, which means I leave the constant by itself, take derivative to the function. Let's call it a constant multiple rule. Next, when I take derivative for f plus g, I take derivative for each function individually. Keep addition sign. Take derivative for each function individually. I get f prime of x plus g prime of x. Let's call the sum rule. Next one, f times g prime. When I take derivative for f times g, I use product rule. Product rule says derivative of the first times the second plus the first times derivative of the second. That's the product rule. Next, when I take derivative for f over g, I use quotient rule. When I take derivative for f over g, I use quotient rule. Quotient rule says the derivative of the top times the bottom minus the top times derivative of the bottom over the bottom square. That's a quotient rule. When we have a function inside another function, if g is inside f, when I take derivative from the outer function first. Take derivative from the outer function first. Keep the inner function the same, and then times the derivative of the inner function. I get f prime of g of x times g prime of x. Let's call the chain rule. Next, derivative of sine x is always cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x is secant square x. Derivative of cotangent x is negative cosecant square x. Derivative of secant x is secant x times tangent x. Derivative of cosecant x is negative cosecant x times cotangent x. So, memorize these formulas. Next, let me introduce antiderivative. If f of x is the derivative of capital F of x, then the capital F of x is called antiderivative of the lowercase f of x. So if f of x, lowercase f of x, is the derivative of capital F of x, then the capital F of x is called the antiderivative of lowercase f of x. Let's look at a simple example first. Differentiate each of the following functions. Differentiate means take derivative. Differentiate each of the following functions. Part A. F of x is x to the power of 4 minus 5x cubed plus 4x squared. How do we take derivative? For f prime of x, here use power rule. Bring 4 to the front, I get 4x cubed. Reduce the power by 1. Next, bring 3 to the front, reduce the power by 1. I get negative 15x squared. Next, bring 2 to the front, reduce the power by 1. I get ax. So that's f prime of x. Part B. F of x is 4x to the power of 3 over 2 minus 6x raised to a half. What's the derivative here? Since we use power rule, we bring exponent to the front. 3 over 2 times 4 is 6. And then reduce the power by 1. 3 over 2 minus 1 is 1 over 2. Next term, I bring 1 over 2 to the front. 1 over 2 times 6 is 3. So I get negative 3 x to the power of, here I take half minus 1. 1 over 2 minus 1 is negative 1 over 2. That's the power rule. So that's the derivative of f of x. Now, in this example here, for the functions in the above examples, f prime of x, in these two examples, f prime of x is the derivative. F prime of x is the derivative of f of x. And f of x is called an antiderivative of f of x, of f prime of x. F prime of x is called the derivative of f of x, and f of x is the antiderivative of f prime of x. Let's look at a different example. Differentiate each of the following functions. Differentiate means take derivative. Part A, f of x is 5x cubed minus 7x. Part B, g of x is 5x cubed minus 7x plus 1. Part C, h of x is 5x cubed minus 7x plus 2. Part D, k of x is 5x cubed minus 7x plus 3. How do I differentiate these functions? Part A, for f prime of x, use power rule. Bring 3 to the front. 3 times 4 is 15. Reduce the power by 1, I get s squared. 7x becomes 7. Part B, for g prime of x, first term bring 3 to the front. 3 times 4 is 15. Reduce the power by 1, I get s squared. 7x becomes negative 7. 1 is a constant, its derivative is 0. Part C, h prime of x, use power rule. I first of all bring 3 to the front. 3 times 4 is 15. Reduce the power by 1, I get s squared. Minus 7. 2 is a constant, its derivative is 0. Part D, for k prime of x, I bring 3 to the front. 3 times 4 is 15. Reduce the power by 1, I get s squared. Negative 7x becomes negative 7. 3 is a constant, its derivative is 0. So that's the derivative of f, g, h, and k. Now, based on this example, let me ask a question. What is the antiderivative of (15x squared minus 7)? What is the antiderivative of 15x squared minus 7? Based on the above example, we can see that for function f of x, g of x, h of x, and k of x, all net derivative equal to 15x squared minus 7. All net derivative equal to 15x squared minus 7. So since net derivative all equal to 15x squared minus 7, functions f, g, h, and k, they are all antiderivatives of 15x squared minus 7. So the answer here is functions f of x, g of x, h of x, and k of x, they are all antiderivatives of f of the function 15x squared minus 7. Because they are derivatives f prime of x, g prime of x equal to h prime of x equal to k prime of x. They all equal to 15x squared minus 7. So the functions f, g, h, and k, these four functions, they are all antiderivative of 15x squared minus 7. So based on this example, you can see that the antiderivative of a function in general is not unique, but they are different by a constant. The only difference is the constant. So they are not unique. The antiderivative of a function is not unique, but they are different by a constant. So note, the antiderivative of a function in general is not unique. In general, they are different by a constant. All antiderivatives of a function are different by a constant. That means for the antiderivatives, the only difference is the constant part. The constant could be 0, could be 1, could be 2, could be 3. The only difference is the constant part. The rest stays the same. So all antiderivatives of a function are different by a constant. The only difference of an antiderivative is the constant. Everything else stays the same. Therefore, in order to write the antiderivative of a function in general form, we need to add constant c. this is capital C, add constant C to an antiderivative. So, for the answer to this question, what's the antiderivative of the function 15x squared minus 7? Instead of saying 5x cubed minus 7 plus 0, 4x cubed minus 7 plus 1, 4x cubed minus 7 plus 2, or 4x cubed minus 7 plus 3, a more accurate answer is 5x cubed minus 7 plus c. That's more accurate. So, a more accurate answer to this question is 5x cubed minus 7x plus c. Instead of saying plus 1, plus 2, plus 3, we say plus c. That's a more accurate answer to this question. That's the antiderivative of the function 15x squared minus 7. Next, let me show you the notation for antiderivative. If the function f of x is given, then the antiderivative of f of x is denoted by capital F of x. Capital F of x is the antiderivative of lowercase f of x. And this notation, f of x dx, also represents the antiderivative of f of x. It's read the integral of f of x dx. This notation is read the integral of f of x dx. Next, let me show you some formulas for antiderivative. First one is called the constant rule. The integral of k dx. The antiderivative of a constant. The antiderivative of a constant is the constant times the variable. The antiderivative of a constant is the constant times the variable. So, in general, we can see that the derivative of 2x is 2. Derivative of 3x is 3. Derivative of 4x is 4. So here we can see that the antiderivative of 2 is 2x. Antiderivative of 3 is 3x. Antiderivative of 4 is 4x. In general, for antiderivative, we need to add constant c. So, therefore, antiderivative of k is kx plus c. That's the first rule, called the constant rule. Next, the sum rule. When I take antiderivative for two functions adding together, I can take antiderivative for each one individually. Next one is called the constant multiple rule. When we're taking antiderivative for a constant times a function, we leave the constant by itself, and then take the antiderivative of the function. When we have a constant times a function, we leave the constant by itself, and then take antiderivative from the function. Next one is called the power rule. Antiderivative of x to the power n is x raised to n plus 1 over n plus 1. We know that for derivative, if I use power rule, I bring exponent to the front and then reduce the power by 1. For antiderivative, do the opposite operation. I add 1 to the exponent. Opposite of subtraction is addition. Add 1 to the exponent and then divide by the new exponent. Opposite operation of multiplication is division. Here I bring exponent to the front. It means I multiply the exponent to the function. Opposite operation is division. So I add 1 to the exponent and then divide by the new exponent. That's called the power rule. Next, antiderivative of cosine x is sine x, because derivative of cosine x, derivative of sine x is cosine x. Derivative of sine x is cosine x. So antiderivative of cosine x is sine x. antiderivative of sine x is negative cosine x plus c. Antiderivative of sine x is negative cosine x because derivative of cosine x is negative sine x. So the antiderivative of sine x should be negative cosine x. The sign is opposite. The sign is opposite. Derivative of sine x, derivative of cosine x is negative sine x. So the antiderivative of sine x is negative cosine x. Antiderivative of sine x is negative cosine x. Since the derivative of tangent x is secant square x, then the antiderivative of secant x is tangent x. Derivative of tangent x is secant square x. So the antiderivative of secant square x is tangent x. And similarly, since derivative of cotangent x is negative cosecant x, the antiderivative of cosecant x is negative cotangent x. The sign is opposite. That's positive, that's negative. So the antiderivative of cosecant square x is cotangent x. Antiderivative of cosecant x is negative cotangent x. And next one, since the derivative of secant x is secant x times tangent x, so the antiderivative of secant x tangent x is secant x. The antiderivative of secant x tangent x is secant x plus c. And similarly, the last one, since the derivative of secant x is negative cosecant x times cotangent x, the sign is opposite. That's positive, that's negative. So if I take antiderivative for cotangent x, if I take antiderivative for cosecant x, cotangent x, I get negative cosecant x. So antiderivative of cosecant x times cotangent x is negative cosecant x plus c. So those are the formulas for antiderivatives. Memorize this formula. Next, based on this formula, let's do some simple examples. Find the antiderivative for each of the following functions. Find the antiderivatives for each of the following functions. First example, f of x equal to s squared plus 4x plus 3. So here, for the antiderivative of f of x, we use capital F represent the antiderivative. When we are taking antiderivative for a polynomial, we take antiderivative for each term individually by the sum rule. Take antiderivative for each term individually. So for the first term, use power rule. Add 1 to the exponent and then divide by the new exponent. For the second term, do the same thing. Add 1 to the exponent and then divide by the new exponent. Last one is a constant. Apply constant rule. Take the constant, multiply by the variable. Last one is a constant. Apply constant rule. Take the constant times the variable. Here the variable is x. Then plus c. When we take antiderivative for the final answer, always add c. And then for the final answer, we can write it as 1 over 3 x cubed plus 2x squared plus 3x plus c. Another example, f of x equal to 2 over x squared plus 5 over x to the power 4. For this example, we can first of all try to bring x to the top, to the numerator. So this function f of x can be rewritten as 2x raised to negative 2. When I bring x to the top, I change exponent from positive to negative. Same thing for the second term. When I bring x to the power 4 to the top, I make exponent from positive to negative. And then take antiderivative for each term individually. add 1 to the exponent. Negative 2 plus 1 is negative 1, and then divide by the new exponent. Same thing for the second term. Add 1 to the exponent. Negative 4 plus 1 is negative 3, and then divide by the new exponent. And then for the final answer, always add constant c. If we simplify the answer, it can be rewritten as negative 2x raised to negative 1 minus 5 over 3 x raised to negative 3 plus c. Or it can be rewritten as negative 2 over x minus 5 over 3x cubed plus c. If I bring the exponent to the denominator, I change exponent from negative to positive. If I bring x from numerator to denominator, change exponent from negative to positive. Next example, f of x equal to 3 square root of x minus 5 times cube root of x. In order to find the antiderivative, let me first of all rewrite the roots in exponential form. 3 square root of x can be rewritten as 3x raised to a half. 5 times cube root of x can be rewritten as 5x raised to the power of 1 over 3. In general, for radicals, square root of x is x raised to a half. Cube root of x is x raised to a third. The fourth root of x is x raised to a 4. The fifth root of x is x raised to a fifth. So in general, the n root of x is x raised to 1 over n. If there's a power, n root of x raised to power m, that's x to the power of m over n. The exponent is the numerator. The index in the front is the denominator. Exponent is the numerator. Index in the front is the denominator. So that's how we write radicals in exponential form. Here, square root of x is x raised to a half. Cube root of x is x raised to a third. Next, I can take antiderivative using power rule. So when we take antiderivative, add 1 to the exponent. Half plus 1 is 3 half. And then divide by the new exponent. 1/3 plus 1 is 4/3. Then divide by the new exponent. For the final answer, always add c. For antiderivative, always add c. Then simplify the answer. In general, dividing by a fraction means multiplying by the reciprocal. So this expression can be rewritten as 3 times 2 over 3 times x raised to 3 over 2. This expression can be rewritten as 5 times 3 over 4 times x raised to 4 over 3 plus c. If we simplify, it can be rewritten as f of x equal to 2x raised to 3 over 2 plus 3 over 20 x raised to 4 over 3 plus c. That's the final answer in the simplified form. Part D. F of x equal to 2x plus 1 times 3x minus 2. For this example, we can try to multiply these polynomials first. If I multiply this polynomial, I have 6x squared minus 4x plus 3x minus 2. If I combine like terms, f of x is 6x squared minus x minus 2. Next, I can use power rule to take antiderivative. If I use power rule, add 1 to the exponent, then divide by the new exponent. Add 1 to the exponent, divide by the new exponent. For constant, apply constant rule. Antiderivative of constant is the constant times the variable, and then always add constant c. When we take antiderivative, always add constant c. Then if I simplify, 6 divided by 3 is 2. I get 2x cubed minus half of x squared minus 2x plus c. That's the answer to part B. Next, f of x equal to 4x to the power 5 minus 2x to the power 3 plus x over s cubed. When we have multiple terms, divide by one term on the bottom, I can split it. Take each term on the top, divide by the term on the bottom. So it can be rewritten as 4x to the power 5 over s cubed minus 2s cubed over s cubed plus x over s cubed. And then when I divide, I subtract exponents. S to the power 5 over s to the power 3. 5 minus 3 is 2. S cubed on the top and the bottom get cancelled. X by itself means the power is 1. 1 minus 3 is negative 2. And then take antiderivative. Take antiderivative. Use power rule. Add 1 to the exponent and then divide by the new exponent. I get 4s cubed over 3. For constant, apply constant rule. Antiderivative of a constant is always the constant times the variable. I get 2x. And then for the last term, apply power rule. Add 1 to the exponent and then divide by the new exponent. Always add constant c. Don't forget constant c. When we take antiderivative, always add constant c. And then if I simplify the answer, 4 over 3 s cubed can be rewritten as 4 over 3 times s cubed minus 2x plus times minus is minus. I can bring x to the bottom, write it as 1 over x plus constant c. This is E. This is part E. F. F of x equal to 4 sine x. Here, number 4 is a constant. Apply constant multiple rule. When I take antiderivative, I leave the constant the way it is. Don't touch the constant. Take antiderivative for sine x. Memorize the formula. Antiderivative of sine x is negative cosine x. Antiderivative of sine x is negative cosine x plus c. So for the final answer, I can rewrite this as negative 4 cosine x plus c. Next, f of x equal to negative a times cosecant square x. F of x equal to negative a times cosecant square x. When I take antiderivative, apply constant multiple rule. Negative a is a constant. It's a constant multiple. I leave it the way it is. Take antiderivative for cosecant square of x. Antiderivative of cosecant square of x is negative cotangent x. Negative cotangent x. So take antiderivative for cosecant square of x. I get negative cotangent x. And then don't forget plus a constant c. If I simplify the answer, I get a cotangent x plus c. Next, f of x equal to secant x times tangent x over tangent cube x plus tension x. For this example, for this function, we need to simplify the function first, and then decide what to do next. How do we simplify this function? In the denominator, I can factor tension out. If I factor tension x out from denominator, what's left is tension square x plus 1, and leave the numerator the same. Next, I can cancel tension x from top and bottom. If I cancel tension x from top and bottom, what's left is secant x over tension square x plus 1. What's tension square x plus 1? If we apply trig identity, tension square x plus 1 is secant square x. If we apply trig identities, tension square x plus 1 is secant square of x. Then I can cancel one of the secant from top and bottom. We cancel one of the secants from top and bottom. If I cancel one secant from top and bottom, what's left is 1 over secant. And if we use trig identity, 1 over secant is cosine of x. 1 over secant is cosine of x. Next, I can take the antiderivative for cosine of x. Antiderivative of cosine x is positive sine x. Antiderivative of cosine x is positive sine x. So the antiderivative is sine x always as c. When we take antiderivative always as c. So the antiderivative of cosine x is positive sine x plus c. Next, find f of x based on the given information. Part A, f prime of x is 4x cubed minus 5x. We know that f prime of x is the derivative of f of x. That means f of x is the antiderivative of f prime of x. So in general, if I know f of x, to find f prime of x, I take derivative. However, if I know f prime of x and I want to find f of x, I take the antiderivative. So if we know f prime of x and we try to find f of x, we take antiderivative. Take antiderivative. 4x cubed minus 4x. Here I use power rule. Take antiderivative for each term individually. Add 1 to the exponent, and then divide by the new exponent. Add 1 to the exponent, divide by the new exponent. And when we take antiderivative, always add constant c. If I simplify the answer, f of x is x raised to power 4 minus 5 over 2 times x squared plus c. That's f of x based on f prime of x. Part B, f prime of x equal to 6x squared minus 4x plus 5. F of 1 equal to a. This is called the initial condition. This is called the initial condition. In general, when we take antiderivative, we use the initial condition to find the constant c. In general, when we're taking antiderivative, we use the initial condition to find constant. Now here, from f prime of x to f of x, I take antiderivative. If I take antiderivative for polynomial, we take antiderivative for each term individually, and then apply power rule here. Add 1 to the exponent, divide by the new exponent. For the second term, add 1 to the exponent, and then divide by the new exponent. Last term is a constant, so apply the formula for constant. Antiderivative of constant is the constant times the variable. That's constant rule. Antiderivative of constant is always the constant times the variable. I get 5x. And then, after we take antiderivative for every term, always add constant c. If I simplify the answer, I get 2x cubed minus 2x squared minus plus 5x plus c. Next, we need to use the initial condition to find the constant c. For the initial condition, I plug in 1 for x. If I plug in 1 for x, f of 1 is 2 times 1 cubed minus 2 times 1 squared plus 5 times 1 plus c. And we know that f of 1 is a. 2 times 1 cubed is 2. 2 times 1 squared is also 2. 5 times 1 is 5 plus c. Here, solve the equation for c. 2 minus 2 get cancelled. Subtract 5 from both sides. I get c equal to 3. And then for the final answer, plug c into the function f of x. So f of x is 2x cubed minus 2x squared plus 5x plus c. c is 3. That's the final answer. That's function as f of x based on the given information. Next, f double prime of x equal to 12x squared minus 12x plus 6. How do we find f of x based on f double prime of x? We know that if I take derivative for f prime of x, we get f double prime of x. So similarly, conversely, if I take antiderivative for f double prime of x, if I take antiderivative for f double prime of x, I get f prime of x. So that means for f double prime of x, if I take an antiderivative twice, I get f of x. So based on f double prime of x, if I try to find f of x, I take antiderivative twice. Based on f double prime of x, if I try to find f of x, take antiderivative twice. Let me first of all take the first antiderivative. For f double prime, if I take the first antiderivative, I get f prime of x. If I take first antiderivative, I get f prime of x. When we're taking antiderivative, apply power rule. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. For antiderivative of a constant, apply constant rule. For antiderivative of a constant, apply constant rule. Taking the constant, multiply by the variable. After we take antiderivative for every term, always add constant c, and then simplify. F prime of x is 4x cubed minus 6x squared plus 6x plus c. Next, from f prime of x, if I try to find f of x, I take another antiderivative. From f prime of x, if I try to find f of x, I take another antiderivative. Take another antiderivative. Add 1 to the exponent, and then divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, and then divide by the new exponent. That's power rule. Next, c is a constant. When we take antiderivative to this constant c, apply constant rule. Antiderivative of a constant is always the constant times the variable. I get cx. This letter c is a constant. When we take antiderivative for a constant, apply constant rule. Taking the constant times the variable. After we take antiderivative for every term, we need to add a constant. Since we use letter c already, here we need to use a different letter called letter d. After we take antiderivative for every term, add another constant. Since I use c already, use a different letter called d. So that's f of x. If I simplify, f of x can be written as x to the power of 4 minus 2x cubed plus 3x squared plus cx plus d. That's f of x based on the given information. Next, part D. f double prime of x equal to 6 vertical x, and we have two initial conditions. F prime of 1 equal to 10, f of 1 equal to 15. Here we have two initial conditions. Based on the given information, if we try to find f of x based on f double prime of x, we must take antiderivative twice. So here, let me rewrite the function first. F double prime of x can be rewritten as 6x raised to a half. Then I can find the first antiderivative, f prime of x. If I take the antiderivative, I apply power rule. Add 1 to the exponent, half plus 1 is 3 over 2. And then divide by the new exponent. Then always add constant c. F prime of x can be rewritten as 6 times 2 over 3. Dividing by a fraction means multiplying by its reciprocal. So divide by 3 over 2 is a sense multiplied by 2 over 3. X raised to 3 over 2 plus c. So if I simplify, f prime of x can be rewritten as 4x raised to 3 over 2 plus c. Next, I can use the initial condition to find c. Plugging 1 into the derivative. F prime of 1 equal to 4 times 1 raised to 3 over 2 plus c. We know that 1 raised to any power is 1. 4 times 1 is 4. And f prime of 1 is 10. Then solve the equation for c. Here c equal to 6. Once I know c, I can plug in c here. So f prime of x is 4x raised to 3 over 2 plus 6. Next, based on f prime of x, if I try to find f of x, I need to take another antiderivative. So based on f prime of x, let's take another antiderivative. When we take antiderivative, apply power rule. Add 1 to the exponent. 4x raised to 5 over 2. 3 over 2 plus 1 is 5 over 2. And then divide by the new exponent. 6 is a constant. When we take antiderivative for constant, apply constant rule, which is taking the constant times the variable. I get 6x. After we take antiderivative for every term, we need to add constant. Since we use c already, let me use a different letter. Let me use d for another constant. Now simplify f of x. F of x can be rewritten as 4 times 2 over 5 times x raised to 5 over 2 plus 6x plus d. If I simplify, it can be rewritten as 4 times 2 is 8. I get 8 over 5 times x raised to 5 over 2 plus 6x plus d. Next, we need to use another initial condition to find d. Now let me plug in 1 for x. If I plug in 1 for x, f of 1 equal to a over 5 times 1 to the power of 5 over 2 plus 6 times 1 plus d. And we know that f of 1 is 15. F of 1 is 15. 5 over a times 1 raised to 5 over 2. We know that 1 raised to any power is 1. So I get a over 5 plus 6 times 1 is 6 plus d. Next, let me multiply both sides by 5. Make it a little easier. Let me multiply both sides by 5. If I multiply both sides by 5, I can make 75 equal to a plus 30 plus 5d. A plus 30 is 38 plus 5d. Then subtract 38 from both sides. 75 minus 38 is 37 equal to 5d. Then I can divide both sides by 5. d equal to 37/5. So for the final answer, plug in d. Plug in 37/5 for d. So the final answer is f of x equal to a/5 times x raised to 5/2 plus 6x plus d. d is 37/5. That's f of x based on the given information. Next example, f double prime of x is -4 cosine x plus 3 sine x, and f prime of pi over 2 is 1. f of pi is 5 pi. Those are two initial conditions. We try to find f of x based on the given information. If we try to find f of x based on f double prime of x, we must take an antiderivative twice. So let's take the first antiderivative. -4 is a constant multiple, it stays the same. If I take antiderivative for cosine of x, I get positive sine of x. Antiderivative of cosine x is sine x, positive sine x. And number 3 is a constant multiple, it stays the same. Next, we take antiderivative for sine x. Antiderivative of sine x is negative cosine x. Antiderivative of sine x is always negative cosine x. After we take antiderivative for each term, add constant c, and then simplify. f prime of x can be rewritten as -4 sine x minus 3 cosine x plus c. Next, let's find c based on the given information, based on the initial condition here. I plug in pi over 2 for x. f prime of pi over 2 equal to -4 times sine pi over 2 minus 3 times cosine pi over 2 plus c. We know that f prime of pi over 2 is 1. Sine pi over 2 is also 1. Cosine pi over 2 is 0 plus c. And then simplify. I get 1 equal to -4 minus 0 plus c. And then I can add 4 to both sides. c equal to 5. Once I know c, I can plug in c. So f prime of x equal to -4 sine x minus 3 cosine x plus c. Here c is 5. That's f prime of x. Next, we try to find f of x based on f prime of x. If we try to find f of x based on f prime of x, take another antiderivative. So take antiderivative. Here, -4 is a constant multiple, it stays the same. Take antiderivative for sine x. Antiderivative of sine x is negative cosine x. And -3 is a constant, it stays the same. Constant multiple stays the same. Next, we take antiderivative for cosine of x. Antiderivative of cosine x is positive sine x. And then take antiderivative for number 5. Number 4 is a constant. When we take antiderivative for a constant, apply constant multiple rule. Apply constant rule. Take 5 times the variable. Take the constant times the variable. I get 5x. And then after we take antiderivative for every term, add constant. Since we use letter C already, then we use a different letter. Say D, letter D. Then simplify. f of x can be rewritten as 4 times cosine x minus 3 times sine x plus 5x plus d. And then we use the initial condition to find constant d. Plug in pi for x and then solve for d. Plug in pi for x, solve for d. If I plug in pi for x, f of pi equal to 4 times cosine pi minus 3 times sine pi plus 5 times pi plus d. And we know that f of pi is 5 pi. Cosine pi is -1. Sine pi is 0 plus 5 pi plus d. Here, 5 pi on the left side and right side get cancelled. I get 0 equal to -4 minus 0. -3 times 0 is 0 plus d. And then solve an equation for d equal to 4. For the final answer, plotting d into function f. So for the final answer, plotting d into function f of x is 4 times cosine x minus 3 sine x plus 5x plus d. Here d is 4. That's the final answer. Next example, f double prime of x equal to 12x plus 10 with two initial conditions, f of -1 equal to 1 and f of 1 equal to 11. Based on the given information, if we try to find f of x based on f double prime of x, we must take antiderivative twice. Let's take the first antiderivative first. If I take the first antiderivative, I get f prime of x equal to 12x squared over 2. Add 1 to the exponent and then divide by the new exponent. Number 10 is a constant. Apply constant rule. I take the constant times the variable. I get 10x. Then after take antiderivative for every term, add a constant c. But the thing is, we don't know here, based on the initial condition, we don't know what f prime is. So we cannot solve for c directly from this initial condition here. We cannot solve for c directly based on the given information here. Next, let's simplify and find f of x. If I simplify, f prime of x can be rewritten as 6x squared plus 10x plus c. Now next, let's take another antiderivative. F of x is 6x squared plus 10x. Add 1 to the exponent, I get 6x cubed. Apply power rule, add 1 to the exponent, I get 6x cubed over 3 plus 10x squared over 2. C is a constant, so apply constant rule. Taking the constant times the variable. When we take antiderivative, apply constant rule. Taking the constant times the variable, I get cx. And then, after we take antiderivative for every term, always add another constant, called constant d. Next, let's try to find c and d based on the given informations, based on these two initial conditions. Let me use the first initial condition. If I simplify f of x, let me simplify first. If I simplify, f of x is 2x cubed plus 5x squared plus cx plus d. Now let me plug in -1. If I plug in -1, I get 2 times -1 cubed plus 5 times -1 squared plus c times -1 plus d. We know that f of -1 is 1. -1 cubed is -1. 2 times -1 is -2. -1 squared is 1. 5 times 1 is 5. C times -1 is -c, and then plus d. If I simplify the constant here, -2 plus 5 is 3 minus c plus d. If I move 3 over, I get -2 equal to -c plus d. Next, let me use another initial condition. I plug in 1 for x. If I plug in 1 for x, I get f of 1 equal to 2 times 1 cubed minus 5 times 1 squared plus c times 1 plus d. Plug in 1 here for each x. And then we know that f of 1 is 11. 1 cubed is 1, 2 times 1 is 2. 1 squared is 1, 5 times 1 is 5. C times 1 is C plus D. Let me simplify the constant. 2 plus 4 is 7 plus C plus D. If I subtract 7 from both sides, I get 4 equal to C plus D. So I have two equations with two variables. Solving the system of equations, I have negative 2 equal to negative C plus D. 4 equal to C plus D. If I add the equation together, I get 2 equal to 2D. C get cancel. Positive C, negative C get cancel. So divide both sides by 2. D equal to 1. Once I know D, I can substitute D and solve for C. If I substitute D here, I get 4 equal to C plus 1. Subtract 1 from both sides. C equal to 3. So here I get D equal to 1, C equal to 3. For the final answer, in function f, plug in both C and D. So f of x is 2x cubed plus 5x squared. Plug in 3 for C, I get 3x. Plug in 1 for D, I get 1 here. So that's f of x based on the given information. That's how we find f of x based on the given information. That's the final answer. Next example. Suppose the acceleration of a particle is known as a of t equal to sine of t, with an initial velocity of 2 and the initial position of 3. Find the position function s of t. Based on what we learned last semester, we know that s of t represents the position or the displacement of an object. S of t represents the position or the displacement of an object. If I take derivative for s of t, I get v of t, which is called the velocity of an object. If I take derivative for the position or the displacement of an object, I get the velocity of an object. V of t represents the velocity of s of t. If I take another derivative, I get a of t. That's called acceleration of an object. If I take derivative for the velocity, I get an acceleration of an object. A of t stands for acceleration. So, from the position or the displacement function, if I take derivative, I get a velocity. If I take another derivative, I get an antiderivative. I get the acceleration a of t. Now, from acceleration, if I take an antiderivative, I get a velocity. And from velocity, if I take another antiderivative, I get s of t, which is the position or the displacement of an object. So in this problem, let's write down what's given first. What's given is acceleration a of t is sine of t. That's what's given. What else is given? We know that the initial velocity is 2. Initial velocity is 2. Means velocity at time 0 is 2. Initial velocity is 2. That means the velocity at time 0 is 2. And the initial position is 3. Initial position is 3. That means the position s of 0. The position at time 0 is 3. That's what's given. Now, based on what's given, we try to find the position function s of t. S of t is also called the displacement function. Here it's called position function. It's also called the displacement function. Now, From acceleration, if we try to find position, we must take antiderivative twice. From acceleration, if we try to find the position, we must take antiderivative twice. So let me take the first antiderivative. If I take antiderivative for acceleration, I get a velocity. Antiderivative of sine of t is negative cosine t. Every time when we take antiderivative, we must add constant c. Now, based on the initial condition, solve for c. Here we know that v of 0 is 2. If I plug in 0 for t, what do I get? I get v of 0 equal to negative cosine of 0 plus c. We know that v of 0 is 2. Cosine of 0 is 1 plus c. Then add 1 to both sides. I get c equal to 3. Then plotting 3 into the velocity function. V of t is negative cosine t plus 3. That's the velocity function. Next, based on the velocity function, if we try to find the position function, we must take another antiderivative. Based on the velocity function, if we try to find the position function, we must take another antiderivative. So, take another antiderivative. I got s of t. Antiderivative of cosine of t is sine of t. Antiderivative of cosine of t is sine of t. Negative sign stays the same. And then take antiderivative for 3. 3 is a constant. Apply constant rule. We take the constant times the variable. Apply constant rule. Take the constant times the variable. I get 3t. After we take antiderivative for every term, we must add another constant called constant d. And then solve for constant d based on another initial condition here. So here I plug in 0 for t. S of 0 equal to negative sine of 0 plus 3 times 0 plus d. We know that s of 0 is 3. Sine 0 is 0. 3 times 0 is also 0. I get 0 plus d. So d is equal to 3. And then for the final answer, plug in 3 for d. S of t equal to negative sine t plus 3t plus d. Here d is 3. So that's the position function s of t. That's the answer to the problem. Next example. A stone is thrown upward from the edge of a cliff with an initial velocity of 8 feet per second. Assume the height of the cliff is 440 feet. Find the vertical displacement h of t and use it to determine how long it will take the stone to reach the ground. So let's first of all write down the given information. A stone is thrown upward from the edge of a cliff with an initial velocity of 8 feet per second. Initial velocity means the velocity at time 0 is 8 feet per second, is 8. Since the stone is thrown upward, so the velocity is positive. If the stone is thrown downward, the velocity will be negative. Also, assume the height of the cliff is 440 feet, which means the stone in the beginning, the stone at time 0 is 440 feet above the ground. The stone at time 0 is 440 feet above the ground. And then we try to find the vertical displacement h of t and use it to determine how long it will take the stone to reach the ground. Do we know more? It looks like we don't have enough information here. Do we know anything more? We know that near the Earth, there's a gravity that pulls objects downward. So for this stone, it's on the Earth. There's a gravity that pulling the object downward. Since there's a gravity pulling the object downward, it generates an acceleration. The acceleration near the Earth is the constant g equal to 9.8 meter per second square. The gravity on the Earth generates acceleration 9.8 meter per second square, or is the same as 32 feet per second squared. In this problem, the unit is feet, so we choose g equal to 32 feet per second squared. So because of the gravity, the stone has an acceleration a of t equal to 32 feet per second squared. Also, since the gravity pulling the stone downward, this acceleration is negative. Since the gravity pulling the object downward, this acceleration is negative. So a of t is negative 32. We know v of 0 is a, h of 0 is 440. We try to find the displacement h of t. So from acceleration, if we try to find the displacement, we must take antiderivative twice. So here, let's take antiderivative twice, find the displacement. If I take the first antiderivative, I get v of t. From acceleration, if I take the first antiderivative, I get v of t. Negative 32 is a constant. If I take antiderivative for a constant, apply constant rule. I take the constant times the variable. That's negative 32t. Every time when we take antiderivative, we must add constant, called c. Next, based on the initial condition, let's find c. We know that v of 0 is a. So if I plug in 0 for t, I get negative 32 times 0 plus c. And we know that v of 0 is a. A equal to 0 plus c. C equal to a. Then I can plug in a for c. So the velocity is negative 32t plus c. C is 8. Next, from the velocity, if I try to find a displacement, I take another antiderivative. From the velocity, if we want to find a displacement, take another antiderivative. Here we use h of t to represent vertical displacement. So take another antiderivative. We get a displacement h of t. Take antiderivative for negative 32t. Here use power rule. Take negative 32 t squared, add 1 to the power, divided by the new exponent. Plus, take antiderivative for a. Since a is a constant, apply constant rule, which says take a times the variable. A times t is at. And then every time when we take antiderivative for every terms, we need to add constant. Here, let me use a different letter, say d. Let me use d as a different constant. If I simplify, h of t can be written as negative 16t squared plus at plus d. Then for h of t, we know that h of 0 is 440. We can use the initial condition to find d. We know h of 0 is 440. We can use this initial condition to find the constant d. If I plug in 0 for t, what do I get? H of 0 equal to negative 16 times 0 squared plus a times 0 plus d. We know that h of 0 is 440. Negative 16 times 0 squared is 0. A times 0 is 0 plus d. If I solve the equation for d equal to 440. Then I can plug in 440 for d. So h of t equal to negative 16t squared plus at plus t. Here d is 440. That's an answer to the first question. Find the vertical displacement h of t. That's h of t. Next question. Use it to determine how long it will take the stone to reach the ground. How long it will take the stone to reach the ground? We know that when the stone reaches the ground, its height must be 0. When the stone reaches the ground, its height must be 0. So I set the height of equal to 0 and solve for t. So for the second question, I set h of t equal to 0 and then solve an equation for t. If I set h of t equal to 0, I get negative 16t squared plus at plus 440 equal to 0. To make it a little easier, I can divide both sides by negative a. If I divide both sides by negative a, I get 2t squared minus t minus 55. Then factor. 2t squared can be split as 2t times t. We try to make the outer plus the inner to be -1. Let me factor 55. Let's try 11 times 5. -11 positive 5. Outer is 10t. Inner is -11t. 10 plus -11 is -1. I get -1t here. So that's the factor form of this trinomial. Then I can set each of them equal to 0. 2t minus 11 equal to 0. T plus 4 equal to 0. Solve the equation for t. T equal to 11 over 2. T equal to -5. Since time cannot be negative, this answer is rejected. So it take 11 over 2 is 5.5. So it take the stone. For the stone, it take 5.5 seconds to reach the ground. That's the answer to the second question. It takes 5.5 seconds for the stone to reach the ground. That's the answer to this problem.